This is an introduction to our project, Automatic Statistician. The goal of the project is to evaluate quality of the dataset with stats parameters and analyze part of the dataset popularity with respect to its statistical qualities. So the goal is the question of what is made by a good dataset. Is the dataset good if, by itself if we like it, or if the dataset is good if it contains rich information? And also, what is meant by a fake or bad dataset? Is dataset bad because it's linear, because it's too linear, or it's too boring, or does it fit the certain characteristic too much? Part of our inspiration comes from the Sloan's gap, where people researched about the preference on what kind of sequences researchers like to research. We can research on what kind of data do people like to do statistics on. So we define the matrix with the parameters not related to statistic first. So the number of variable and the number of level of categorical variables. We're interested in the shape of the data, so whether it's normal, whether it's linear. We are also interested in if the data has a smooth curve or has some smooth characteristics. So we use the low-S model to fit the curve, and use the model performance to see if there is a smooth folded curve that's non-linear but also monotone and single valued. And we use the performance of KNN to also evaluate the smoothness of the data. We can evaluate the we can build a matrix on complexity of the data, so whether it has a fractal dimension and what's the entropy of the data, and also whether it's possible to build a robust predictive model on the data. Call that data predictability. We can use the performance of the predictive model to build a matrix on top of that. The implementation of the code is in the Python notebook, but we skipped the evaluation of the correlation, the fractal correlational dimension, because it's too low and didn't finish. And then we evaluate the performance. In the parallel study, it turns out lots of the variables are not directly related to popularity, but a closer analysis revealed that there's a negative relation between the proportion of eigenvectors that's needed to represent certain variation in the dataset and the popularity, and the popularity goes down if that proportion goes up. Also, there's some relation between the low-S model performance and the number of hits on the data. Also, we did density plot for that, but we're running out of time to do more complicated analysis. Thank you for watching the video.